If I take minus delta here, what will you get? F of x naught minus delta is going to be equal to f of x naught minus delta d by dt of f x naught plus delta squared d squared by dt squared f x naught plus again get something of this kind. Right, you get an expansion that looks like this. Right now, if this x naught has to be a maxima, then both of these values should be less than f of x naught. Yeah, which means that minus delta into d by dt f of x naught plus all the remaining terms should be less than f of x naught, and here also you should have less than f of x naught. Now, if I take delta to be sufficiently small, all these other terms are going to be negligible in comparison to this term. Therefore, you can, as delta tends to 0, what you will get is delta into df by dt x naught should be less than 0, as well as minus delta into df by dt x naught should be less than 0. Now, delta is a positive number because you are taking delta minus delta, right? So, if delta is a positive number, what this essentially means is that, so you have a number here, df, you have delta into df by dt x naught is greater than 0, is less than 0, as well as minus of that number is less than 0 or less than or equal to 0. So when can a number be when can a number and its negative both be less than or equal to 0? When it is 0, and that only happens when df by dt is equal to 0. That's why you have that first condition. You think of it a little further. If you assume that df by dt is equal to 0, this term will vanish off. Then you look only at the next term. Right? Now you want both of these to be less than f of x naught. They will be less than f of x naught only when this is negative. That's why you have del squared f by del t squared should be less than 0. That's essentially how you derive these conditions for maxima and minima. So what does this condition for maxima and minima essentially capture? It captures the fact that I move in any direction, your value is going to reduce for a maximum, and you move in any direction and your value is going to increase for a minimum. Yeah, this kind of becomes a Mahamantra of optimization. Yeah, a point is a maxima if it reduces along all directions. A point is a minima if the value increases along all directions. So I move in any direction, it should increase or decrease. Now this is universally true for any vector space.